Here's the section 2.1 to 2.5 review. Number 3, calculators are still not allowed, and each of these we are looking for the limits if they exist. So in part A, we want the limit as x approaches 2 on f of x if f of x is given to us as this piecewise function. So if I want to do part A, I can write down, first of all, I'm approaching 2, which is a joint on this piecewise function. So I cannot compute the limit unless I look at the left-hand limit and the right-hand limit. So I'm going to approach 2 from the right, and I'm going to approach 2 from the left, and then I'm going to compare the two outputs. So if I'm coming from the right, that means I'm working with numbers that are a little bit larger than 2. Looking at my branches domains, numbers that are bigger than 2 belong between 2 and 8. So that means I will use this bottom branch. For this one, if I want numbers that are smaller than 2, I will again locate the branch whose domain deals with numbers that are smaller than 2. Here my x is smaller than 2, so that means I will use the top branch. Now my job is to plug 2 in and see if it causes a problem. If it doesn't, direct substitution works and I can get each right and left side limits. Plug the 2 in, I get a 4 times the log natural of 2. Here when I plug in 2, I get a log natural of 2 to the 4th. You could have also written a 16. But the reason I left it like this is because we cannot identify whether the two-sided limit exists unless we can see whether the left and the right limits match up, if they're the same. So if you remember your old log rules from pre-calculus, this 4, which is an internal exponent, becomes an external coefficient using properties of logs. So if you write it this way, we can see that they now match, and that will be the same as the two-sided limit. Actually, let me put an f of x here. So my correct answer is 4 ln of 2. So now let's look at b. With b, we again are approaching the joint of the piecewise function. So I need to examine what happens as I approach 3 from the right and as I approach 3 from the left, and I will compare the two limits to see if they're the same. If I want to be bigger than 3, I need to find the values in the domain that are larger than 3. That occurs here, so that means I'm going to be looking at the limit for the bottom branch. Here, if I'm coming toward the left, or from the left, excuse me, then I'm having numbers that are a little smaller than 3. This branch corresponds to numbers that are smaller than 3, so I will use an ln of x cubed. Now, just like I did in part A, I'm going to plug the 3's in. So I have a 3 ln of 3, and I have an ln of 3 cubed. Notice this is the exact same property that we used up here, so I can take this 3 and move it in front. That will give me a 3 ln of 3, which means now my right-hand limit and my left-hand limit match. Because of that, I can write that the two-sided limit as x approaches 3 of f of x will be 3 ln of 3. Let's look at the very last one, and then we'll move on. So with the last one, C, we have the limit as x approaches 0 from the right. Notice that we have a branch that is going to change or shift. We've got our joint at 0. So I've got a limit as x approaches 0 from the right and a limit as x approaches 0 from the left. If I want to approach from the right, I need to identify what branch deals with numbers that are larger than 0, and that is this bottom branch. So I'll have an x squared times a log natural of 5. If I want to approach 0 from the left, that means I'm going to plug in to the branch that deals with numbers that are smaller than 0. So that's this top one, 5 plus ln of the absolute value of x. Now if we look here, we can plug the 0 in. It doesn't cause us any trouble, and we get a 0 times a log natural of 5, which is 0. here we have a little bit more trouble because zeros are not viable input for log naturals. But numbers that are close to 0 are going to be moving along that asymptote that we see on the log natural graph. So if I plug in something super close to 0 in a log natural and I take the absolute value of it so it becomes a positive number here, then the log natural will spit out a negative infinity. And the negative infinity plus a 5 is still going to be negative infinity. Notice that these two do not match, so that means the two-sided limit as x approaches 0 is not going to exist.